And last time we had this analysis, and we were able to make our sampling distribution, which is right here, and we were also able to identify that the sampling distribution has a mean that is the same thing as the mean of the population, and we also were able to identify the value of the standard deviation of the sampling means. All right, we need both these values to construct our standard deviation function and also to get the cumulative frequency distribution function. Alright, we need this to be supplied on Excel, if you remember. Alright, but before that, we also need to know what is the statistic that we're going to test. But before we do that, I wanted to clear something out. A while ago, I said that the H0 has no effect. That is correct. That means that the initial mean and the mean that we're testing is essentially just the same. So let's call this the initial mean and the mean that we're testing. On the alternative hypothesis, it is the opposite of the null hypothesis, and on the alternative hypothesis, what we're saying is mu naught is not equal to mu I, but we have two choices. It's either that mu naught is, it's either that mu1 is more than mu naught, or it's either mu1 is less than mu naught. Right. So those are the two choices that we have when we say it's not equal. But in this case, we choose it to be an increase, and hence we choose this part. And obviously, when you say that the new mean is more than the mu naught, then it would be located somewhere here on the right, and that's why it's called a one-tail analysis. And I hope that's quite clear to you. But if you did not choose between these two and you just say that they're not equal, then you're gonna choose on the right and you're also gonna choose on the left, and that becomes a two-tailed analysis. Again, it would become a two-tailed analysis if you did not choose between these two and you just said not equal. But since we chose and we said that it's increased or more than, then it's only the right tail that we're looking at. Alright, the next step in this analysis is for us to determine the statistic that we want to test. We wanted to determine this. What is this mu1? And we can get it from the sample. And it says that in the problem they sampled and had a total of 552 fat content. That 552% seems to be awful large. And well, but that is the total fat content. So if there's 30 men, and it says that in 30 men there's a total of 552% fat content, what's the average? What's the average, or what's the x naught of that? So that's equal to 552 all over 30, since 552 is a total, right? So let me grab my calculator and see what the value is. Alright, let's type it down. So that's 552 divided by 30. So the average is 18.4%. So let's write down that. This is the statistic we wanted. So if we go back to our sampling distribution, we understand that it is somewhere here, but we don't know exactly where it is. That's why we need to compute for its z-score. But in that case, if you want to compute for the z-score, you can just look at the table and figure out what the probability is. But since we are going to use the cumulative distribution function, we need to know exactly what is this value. And now remember, you said that you wanted to know whether this mu1 right here is more than mu naught, right? So it means we wanted to know if it is indeed more than mu naught. And for us to know that, we need to understand whether this 18.4 belongs in this distribution. And you understand how we did that before. we need to determine the critical value, and we need to figure out whether 18.4 should come out or shouldn't come out of this distribution. So first we need to understand where it is in the distribution, and for us to do that we need to get its probability of occurrence.